Hello guys, in this video we're going to talk about worksheet 1.3a, the growth factor. So in this worksheet we're going to use this formula, the a equal to p times 1 plus r percent to the power of n. So for the 1 plus r percent is calling as the growing factor or the growth factor. And actually the n, which means that the number of periods. So how many times of the things is going to be growth. And then just be careful about this a and the p. The a is representing our new value or our future value, and the p is our old value. So in the timeline, you need to think about what is happened first. If p is happened first, then a is going to be equal to using the p times 1 plus r percent to the power of n. And that's how we calculate the whole thing. Just remember that a means the new value and the p is representing the old value. Alright, so for the first questions, we have the value of the stem increased by 5.8% every year. So this is the growing rate, but the growing factor or the growth factor is going to be equal to 1 plus 5.8%. So its value was 12,000 15 years ago. So they're asking about finding out the current value. So if you draw a timeline first, this is our timeline, isn't it? So this is the current value, and this is the value is 12,000, and which is 15 years ago. So which one is happened first? The 15 years ago things happened first, that we have the current value, isn't it? So in this value, we're going to think about which one is our a. The new value is going to be the current value, and p is going to be the value of 15 years ago. So we can set a value that the a should be equal to p times 1 plus r percent to the power of n, so that the a, the current value, is something we want to calculate, is going to be equal to the past value, or the value of 15 years ago, which is 12,000 times 1 plus r percent, which is 5.8%, to the power of how many years? 15 years. So if we use our calculator, 12,000 times 1 plus 5.8%, all the thing to the power of 15. So we can get the answer here is going to be equal to 27955.44. So correct to the nearest dollar, which means that we need to think about on this digit. Then we think about the next digit is going to be 4, which is smaller than 5. So we're going to delete all of the things. So it's going to be equal to 27955. Correct to the nearest dollar. Okay. So for the second questions, the height of a plant is increased 1% every week. So our growth factor, the growth factor is going to be equal to 1 plus 1%. And then change to decimal, you have 1.01. And if its current height is 206 cm, find the height 13 weeks ago. Okay, so we still draw a timeline here. This is our future value. So this is our current, and the value is 206 cm. And then they're asking about find the height 13 weeks ago. So that's something happened before. So at here we have 13 weeks ago, then that is equal to something unknown. Okay, so as the current one is actually happened next, so the current one will be our a, and then for the 13 weeks ago, the value should be the p, the past one, isn't it? And we can use our formula, the a equal to p times the growing factor 1 plus r percent to the power of n. The a is equal to 206 cm, isn't it? The p is the value that we want to find out, and the 1 plus r percent, which is 1 plus 1%, to the power of 13 weeks. So to the power of 13. So we change all the things to the left hand side. We got the p is actually equal to 206 divided by 1.01 to the power of 13. Then if you're using your calculator, 1.01 to the power of 13, then it's actually equal to 181.004 something. So as we want to the nearest cm, so we think about here, we think about the integer digit, and the next digit is 0, so we delete all of things. So p is equal to 181 cm, and it's going to be correct to the nearest cm. Okay, so that's for question 2. So now we are going to do question 3. The number of bacteria in a sample growth at a rate R% per hour. So our growing factor, or the growth factor, is going to be equal to 1 plus R%. And now we have, it's known that the number of bacteria at 3 p.m. and 4 p.m. are 208 and 432. So they're asking us to find out what is the value of R. So first of all, to decide which one happened first, we have two situations in it. We got a 3 p.m. here, and we got a 4 p.m. here. Because 4 p.m. is 1 hour after 3 p.m., so 4 p.m. happening next. So 4 p.m. is equal to 432. 3 p.m. we have 288. So again, we're using our formula. The A is equal to the P times 1 plus R% to the power of n. Because 3 p.m. after 4 p.m. is just 1 hour after, so A is actually equal to 432. So once again, A is the future value, or the things happened nearest to our, or the new value. Because compared to 3 p.m., 4 p.m. is actually the new value. So that's our A. And P stands for the old value, or the past value. So it's going to be 268. So 288, 288. And then we don't know the R, so 1 plus R% to the power of n. Then n is just passed for 1 hour, so it's to the power of 1. So now we can say that 432 divided by 288 equal to 1 plus R%. Giving that the R% is equal to 432 divided by 288 minus 1. Then you're using your calculator, then you can get this equal to 0.5%. Sorry, it's not 0.5%, it's actually equal to 0.5, so that the R is equal to 50, because what we want is 50%, isn't it? Okay, so that's for question A. And then for question B, they're asking about what is the number of bacteria at 7 p.m. So we think about this. So this is our 3 p.m. So that's our starting point. We have 4, we have 5, we have 6, we have 7. So how many hours is passed? 1, 2, 3, and 4. So we can then just using our formula, the A is equal to the P times 1 plus 50% to the power of 1, 2, 3, 4, so to the power of 4. And as our P is our present, the past value, which is equal to 288, so that A is equal to 288 times 1.5 to the power of 4 will give you the answer of 1458. Okay, so that's for question B. And I want to finish for question C as well. So think about it is from 3 p.m. all the way to 1 p.m. So what we want is something past, because this is 3 p.m., isn't it? Then before 1 hour is 2 p.m., before 1 hour is 1 p.m. So now the 3 p.m. is our new value, and then the 1 p.m. is our past value, or the old value. Okay, so just substitute the whole thing. You want to find out the A is equal to the P times 1.50% to the power of 2, because that's 2 years passed. So our A is the future value, which is the 3 p.m.'s one, so it's 288. P is something that we don't know, and what we want is just 1.5 to the power of 2, so that we have the P is equal to 288 divided by 1.5 squared. Will give you an answer of 128. Alright, so that's for question 3. So in question 4, the annual expenses of the company is increased by 20% every year. If the annual expenses this year is 4 million, so this year is 4 million, after how many years will the expenses exceed by 8 million? So which one happened first? The thing is this year is happened first, so that's our P. And then they're asking about after n years, the expenses is going to exceed 8 million, sorry. So that's our amount. So what we want is the amount is equal to the P times 1 plus R%, which is 20%. We don't know the years, we keep an n. And what we want is the amount is greater than 8 million, so that the P is actually 4 million. So we want the 4 million is times 1.2 to the power of n is greater than 8 million, isn't it? So now we have 1.2 to the power of n is greater than 2. And then how can we solve for this question if we don't have a power of n here? So what we're going to do is to using the log and take a log of both sides. So the log of 1.2 to the power of n is greater than log of 2. So that n log 1.2 is greater than log 2. So that the n is greater than log 2 divided by log 1.2. Then using your calculator, then you can get answer is n is greater than 3.8 years. So that as the year should be in integer, so that after n years, and then the n is equal to 4 in this times. So after 4 years, the expense is going to be expanded by 8 million. Okay, so that's for the worksheet. If you have any question, don't hesitate to ask me.